Alright, so we're going to start looking at what is called the intercept method. And the intercept method is going to set us up for defining a line in a more generalized method. But in the intercept method, we're going to define what an intercept is. Now, the intercept means is we're looking at a point that intercepts or crosses one of the axes. And so we'll have two intercepts that we'll talk about. There'll be the x-intercept and the y-intercept. Now, the x-intercept is when the point where the line crosses the x-axis, and the y-intercept is the point where the line crosses the y-axis. Which makes sense when we talk about them, but there's a mathematical peculiarity to these that we'll want to pay attention to. So what we'll do is we'll get a graph here, an axis here, so that we can do a graph. So there's my x and y axis. And we're going to look at the linear equation x plus y equals -3. We're going to make an xy table. We're only going to look at two particular values. The first value we're going to look at, get my xy table down here. So, x, y. We're going to look at, well, what's the value of y when x is 0? So when x is 0, put 0 in here, plus y equals -3. And the only thing we have left on the left-hand side here is y equals -3. So when x equals 0, y is -3. So I come and I plot this. So I start with x equals 0, and I go down 3, 1, 2, 3. And there's my point. This point is 0, -3. Now here's where the naming convention comes in and can throw people off a bit. This is crossing the y-axis. So this point is called the y-intercept. Right? It's crossing the y-axis, so it's the y-intercept. The y-intercept is the place on a line where x equals 0. And that's the part you have to remember here, is the intercept, the opposite variable, is 0. So if we want to find the x-intercept, we look at where y is 0. And so where y is 0, I'll put 0 in for here. X plus 0 equals -3. And so all x has left to equal is -3. So I start here, 1, 2, 3, go over -3. But keeping y 0, I don't go up or down. And so now I have the point -3, 0. And this is the x-intercept. And the x-intercept is where y equals 0. So notice here, x and y. Right? The x-intercept, y equals 0. The y-intercept, x equals 0. And then we'll come back and we'll connect these points. Let's see if I can get my ruler to connect these here. I get on that intercept and on this, and oops, and this intercept here. Since I made the equation red, I'll make the line red, and there's our line. And any solution to this equation will lie on this point, or on this line. But we can use the intercepts to draw this rather quickly. And that's what makes the intercepts really, really useful, is that we're putting in 0 for one of the variables. So we don't have a complex solution defined. We usually will only have one division. But you need to do it twice. Once when x is 0, and once when y is 0. When y is 0, you're looking at the x-intercept. When x equals 0, you're looking at the y-intercept. And we'll find that the y-intercept is a very important value for when we define more properties about lines.